How do residuals show observed versus predicted values in regression? Imagine you have a magic crystal ball that predicts future sales based on advertising spending. But sometimes the predictions are off. How do you tell how far off they are? That's where residuals come in. Residuals are just the differences between what actually happened and what the model predicted. If you have a data point where the actual sales were 100 units and your model predicted 95 units, the residual is 5. That means the prediction was a little low. If the actual was 90 and the prediction was 95, then the residual is -5, meaning the model overestimated. Residuals are like the report card for your regression model. They tell you how well your model is doing for each data point. When you calculate residuals, you subtract the predicted value from the observed value. This simple calculation shows whether your model is underestimating or overestimating. Positive residuals mean the model predicted too low, while negative residuals mean it predicted too high. If residuals are close to 0, it indicates the model is pretty accurate for that point. Now, looking at residuals alone might not tell the full story. To really understand how well your model fits, you can plot these residuals against the predicted values or the input variables. If your model is good, the residuals should scatter randomly around 0. There shouldn't be any pattern or trend. If you see a pattern, like residuals increasing with predicted values, it suggests your model might not be capturing some aspect of the data. In Python, calculating residuals is straightforward. After fitting a regression model using libraries like statsmodel or scikit-learn, you get the predicted values easily. Then, subtract these from the observed data points to find the residuals. You can store these residuals in a list or array. To visualize, you can use matplotlib or cburn to create residual plots. These plots help you see if the residuals are randomly spread, or if there are issues like heteroscedasticity, which is when the spread of residuals changes with the predicted values. Checking residuals is a key step in regression analysis. It helps you see if your model is doing a good job or if it needs adjustments. By examining how residuals behave, you can identify problems like nonlinearity or outliers. This process is essential in Python because it allows you to refine your models and make better predictions. In summary, residuals show the difference between what you observe and what your model predicts. They are a simple yet powerful tool to diagnose how well your regression model is performing. By plotting and analyzing residuals, you can spot issues and improve your model for more accurate data analysis in Python.